Yeah, okay. So I'm Derek, and from the Department of Physiology. I recently finished my master's. So I don't use Pandas too much, but I always felt like it was a very helpful library for tabular data. So I mean, there's lots of different people who would want to use it. I was expecting more people who had maybe a background in R and wanted to learn about Pandas because it's sort of a gateway into Python, I think, for people who have more R experience. Yeah. So basically what I prepared today also was in a notebook. So there's this way of working through data or working with Python that's good for reproducible analysis in the Jupyter notebooks. So essentially you can, it's not just for Python, you can do your analysis in R and other languages as well, but it started off as a Python thing. And it's useful because you can write and mark down and sort of explain what's going on and have these code cells where you can do your analysis and then have some output right beside. So basically you can do, I guess, what's called like literate programming, where you could then package this up and pass it on to someone else and they'll understand what you've done. So I don't know, has everyone got it on their, like, do you have Pandas installed? Did you download the notebook or? Okay, so to some extent I was thinking it might be better maybe if you even just started with a fresh notebook. I know it's always good to maybe code along, but I didn't necessarily trust myself to just be doing it on a whim. So it was nice to have it all there, and now I can basically just read through what's going on. So yeah, as long as you've got the data set, we can start. And if it's in the same folder as the notebook, then essentially what I've got on the first wall, so I skipped right at the top, what you want to be in the libraries that we care about. So Pandas, NumPy, and later on Matplotlib to plot things up. So Pandas has a bunch of data structures that are built on top of NumPy. NumPy allows for vectorized computation so that it speeds things up in Python. So just briefly to go over the objectives, what we want to be able to do is read tabular data, so like a big spreadsheet, access different parts of the data, isolate different ones that we care about depending on like what questions we're asking, and then hopefully generate some plots that can tell us something about the data. So like Lena mentioned, there's a lot of walkthroughs and tutorials on Pandas online. So I accessed a bunch of them. What I wanted to do is sort of do something similar to like software carpentry workshop. So I found a set of lessons, which I linked to in the resources here, where someone went through an analysis of the Gapminder data. And I just changed some things depending on what I felt was useful. Yeah, so there's a lot out there. Also, just the documentation's pretty extensive and useful. So yeah, in this library, Pandas, it introduces two data structures. There's a series and a data frame. Right off the bat, what we're doing is creating a data frame, and it's pretty easy when you just say p.readTable. So in this case, it's a table because the data is separated by tabs. Usually there are CSVs, and there's all sorts of different sorts of import options. So in some cases, like I know you could, instead of having to scrape a website, you might be able to do like pandas.readURL, give it a URL, and it might be able to actually clean it up pretty quickly, and you'll just have like a data frame from a URL right away. You'll probably still have to do some cleaning of that data, but it's really handy to get things done quickly. So in this first cell, basically p.readTable reads the table, and then when you just put in df, it shows you the whole data frame. So it actually doesn't show you the whole thing because there are many rows here. So you can see if you scroll down at some point, there's just a lot of dots, and we see the top. starts with a bunch of countries with A, and then the bottom where there's some countries with Z. So it also tells us the size of this data frame. So we've got over 1,700 rows, and there's 6 columns. So I guess I should execute all these.
The notebook that he's using and also the data set is in the event description.
Yeah. So the first command I went through here is just type df. So I want to see what the type of what we're looking at here. So it's a specific object that is a data frame, and each of the columns within here, if you access them individually and then you wanted to look at type, you would see that they're a series. So a data frame is made up of multiple series. So just the quick ways of seeing what we're looking at. The first thing you want to do is just look at the data frame, see what's going on there. It's pretty obvious that the first column is some countries, the second one is the years, and then there's also there's the headers, which tell you what these are. So yeah, we've got df shape and df.columns, and you can, depending, in our case, we only have 6 columns, but sometimes there's a lot of them, and it'll give you a list of all these columns here. So we see country, year, pop, continent, life expectancy, and GDP per capita. And yeah, so I'll execute these. df.head. So if anyone has gone through one of these lectures where we go through the shell, there's this head command. So it, by default, will give you the first 5 rows of the data frame, but you can also pass it an argument. So in this case, df head with 6, and you get the first 6. And there's a similar command, df.tail, and you get the last 5 by default, or you can give it an argument to see how many you want. So here we have df.info, and it gives you some info on each of the columns. So we're seeing there are a total of 6 columns, country with 1,704 objects, and then it'll tell you country is an object. In the year, the data type in there is an int, population is a float. So it just is giving you more information about what's in the data set. So in our case, this is actually pretty clean, so it's not too confusing. You can say D types to get you just specifically what data types are in here. So now we can finally get to something that's a bit more like actually analyzing the data. So df.describe, I know there's similar functions in R, but in this case, it's just giving you summary statistics on all the numeric data. So if you remember before, we had 6 columns. There was country and continent, and those have disappeared. But that's because you can't really get a count or a mean. Well, you can get a count, but you're not going to get a mean for different country names. So in this case, like the mean year doesn't really mean anything, so you still have to think about what these numbers mean. But it's a good way to especially if you want to think about what might be outliers in your data. You can see minimum values and the 25, 50, and 75 percentile maximum value. So in this case, we can see right away from the year that it's between 1952 and 2007. The life expectancy values are a little surprising, but yeah. I guess we'll take a look later. So the first thing we want to do, because we don't just want to work with the whole table, we want to be able to select specific rows or columns, things that we care about in different ways, because yeah, that's what we want to be able to do. So the first things first, there's multiple ways of selecting columns. So in this first case, I've got df, which is our data frame, and I want to select multiple columns. So I'm passing to, in brackets, a list of the names of columns that I want. So in this case, I have a list with year, exp, and that gives me those two columns. Alternatively, what you could do is like make this into a list. Column list equals, and maybe we care also about country, and then you could just pass that in here, and you would get country as well. So that's a way of selecting columns. Alternatively, if you go down to the next cell, you can do it more rapidly just with this dot notation. So here I just did df dot life expectant, or life exp, which is the life expectancy, and it just returns those values. So I put in a little comment here that this wouldn't work if, for example, you have a column name that has spaces or other issues, because you're not passing a string here. So just so you know. So one thing that I put up earlier was the describe function. So in this case, we care about the categorical data. So I'm selecting country and continent, and if you do describe on it, we're seeing the count is the number of rows, 1,704. The unique values, so there's 142 unique countries within that column and 5 continents. I'm actually not sure what top means, because I think I did it before and it gave me a different country. Because I think, as far as I know, they're all there just as many times. Yeah. So also you might want to select rows specifically. So if you go through the documentation, this is something that confused me for a bit. There's 3 ways of selecting rows. So it has df.iloc here. So you pass in a specific number to get a row, and that, if you look at the data frame, it's got an index on the left with all those numbers. So basically, index number 0 in this case starts with Afghanistan in 1952. You could pass 1,000 and see Mongolia in 1972. I'll leave that one. You can also pass a list of index values, so then you would get multiple values here. So that's what I did here with df.iloc, and then passing a list of specific ones. If you're familiar with slice notation elsewhere in Pandas, you can do that as well. You just have to know what specific values you're looking at here. So in this case, I'm selecting from 0 up to 5, so it's non-inclusive. So you can tell there's 5 values here, but it doesn't include 5. The row stops it with an index number 4. Alternatively, there's df.loc, so it's for label-based selection. So in this case, what I also did was made a new data frame, country index, and df.setIndex. So our data frame before had the indexes over here as just numbers. So when I did setIndex, it took the column with country and put this into the index, just so that you could get an understanding of what this means. When I do country underscore index, which is the new data frame, .loc Canada, it's giving me a data frame where the index has just Canada in the value. So you could also set index with a list. So there's hierarchical indexes where you have more than one value. So if we do, I guess, continent. And then let's take a look what happened here. So here you can see what's called a the hierarchical index, so it's got continent Asia and then all of these within Asia. So if you, well, it kept the same order, but you'll see others with Asia, like Yemen here. And then if I wanted to select, I could select here Americas, and you see a bunch of different countries, Argentina, Bolivia, others. And if you want to get more specific afterwards, that works. Yeah. So I think one thing here is you can't just say straight Canada if there's two indexes. I don't think that'll work. Yeah. You've got to pass both. Oh, what did I do? Okay. In that case, it didn't work just because I put a space before Canada and it didn't match. Yeah. One other thing you might see in if you're going through a lot of these tutorials is df.ix. So it's another way of indexing, and essentially it's supposed to be smart, where it would either work with like iloc or .block. So either one, it would know if you're using an integer like index number, or if there's the label based, and it would figure it out. The problem is sometimes you have a label that happens to be an integer, which maybe you shouldn't be doing, but you do, and then it's not as robust of a way of selecting. So that's why I just didn't include it here, but you'll see it in a lot of the walkthroughs. Another way of selecting data is just with Boolean indexing. So in this case, what I want to do is select all the rows where there's a large population. So I'm making a new data frame here, and I called it large_pop equals df. So that's our original data frame. And then you're passing in a specific Boolean condition. There you go. So here the condition is where the population in the data frame's population is greater than lots of zeros. I can't read this. There you go. 300. Well, yeah, 300 million. Yeah. So I do that, and then our data frame large_pop shows up. So you can see something that I just thought was interesting. You can only see India and China that show up until 2007, when the United States finally breaks that barrier. So one way of looking at specific values that show up within this data frame is with a unique function. So when I'm doing here, when I say large_pop, I'm selecting the column country. So essentially, just by this, I'm selecting that, and then I'm calling unique. And I'm just seeing what unique values are within there. So it gives me a list with China, India, and the United States. So now I know that those are the countries where at some point in time within this, where my data was collected, their population was greater than 300 million.
If you were going to try and use .iloc to find a certain row of that, right? Would you use 701 or from the original data frame, or
yeah?
I don't know how far down this.
So how would you know what row you want? I guess would be the question. So if you
so it's, you use the same index from the
mm-hmm.
Okay.
Yeah.
If you block. Block is the number of rows, iloc is the number of rows.
Okay, I see. Right.
Because the number of rows doesn't have to be a number.
Yeah. Sure. That's...
Yeah. So the next thing I wanted to include here was just chaining together multiple criteria. So I put multi-criteria is a data frame where the country in that data frame is equal to Canada, and also where the year is greater than 1990. So one easy thing to mess up here is just not putting in these brackets. So it works now, but if you don't, well, see, it works that way. But we had seen before where there was just one Boolean criterion, and now we're chaining them together. So this is what the data frame looks here. You can also say or. So either the country is from Canada or the year is greater than 1990. So this will give me a much bigger data frame. Basically, all the countries where this data was selected after 1990, or if the country is from Canada. So much bigger. And you can see at the bottom 500. So I guess I have the answer here. How many unique countries are there in our data frame? Years. So we already looked at that basically in different ways. It was 142 countries as far as I remember. Yeah, so you can do that. So len is something, if you're using Python, it's just the length of an array or list. If I did this, it'll just give me the unique names in the whole data frame. Yeah. All right. So I put in a few little exercises in here too. So the first one was write a function, print stats, that will print a given country's life expectancy, population, and GDP per capita in a given year. So yeah, let's see if we can do that. I'll give you some time, and you can put your hand up if you don't get it to work. Yeah. Does anyone? Okay. So is anyone actually trying to do this? Or yeah. Okay. Yeah, that's a good idea. Also, like. Yeah. Should check that at the beginning.
Fun.
Are you using Pandas?
That's all I know.
I guess because you're running my computer's a little funny now too. Yeah.
And they're not more fixed. Yeah. They're not fixed like
What's what are you? Oh, yeah, one's where everything is like the notebook's not.
You download the problem required.
I downloaded it.
If you had a phone call, I think you download it.
No. Yeah.
Yeah, but yeah, don't. Anybody else have any problem?
What's that?
Anybody else have any problem about this?
It is.
Yeah, you can, so you got it there, right? Yeah.
That's the exact
You get that.
So this is basically like a recap of what we were doing, or what I showed earlier. So just moving on. I specified what we care about here. So I said printing the life expectancy, GDP per capita, and population of the country in a specific year, which we pass to the function. So I have a list here for those things, life expectancy, population, and GDP per capita. Then I just say printing statistics for this country and in this year. And then we're selecting, so in the data frame where the country is equal to the country that I told about, and where year is the year that I care about, and then selecting specific columns. So, that, there. So in Canada, 2007, a life expectancy of around 80. 34, 33 million people. So yeah, the 251 here is just the index for that specific row. Right. So we'll just move on to this group by method, which is useful for splitting up data depending on what we tell it. So in this case, what I'm showing here is grouping the data by specific continent. So it's helpful if we want to repeat an analysis that we're doing on like all of those groups. So in this case, what we're just doing is showing, we're selecting specific stuff that we care about and getting one row out of it. In another case, what we might want to do is apply an analysis to a whole continent, but you don't want to do it once for one continent and then try to do it another time for another continent. Another time, what you're doing is you're just saying group by continents, do this analysis, and do it for all of them. So that's where it's helpful. So just at the top here, what I'm doing is making this group by object. So when you do data frame like df.groupby, and then you pass it what you want it to group by, it's going to give you this group by object. So that's what I'm showing here. Say continent equals df.groupby continent, and then I'm getting this, when I just type out continents, it's telling me, it's returning this data frame group by object. So to me, that's sometimes a little confusing because I want to see what data I just sort of organized, or like how I shaped it. well, here what I'm doing, when continents, so there's 5 continents and what we cared about. So that's why it's saying 5. And there's this next one, continents.first. So essentially what it's doing is returning the, out of that group by object, the first element in each of the sections for the group by. So for me, I found this helpful just to visualize that object. So then there's obviously multiple countries and multiple entries within each continent. Yeah. So I have a little question here. It says list the names of continents and number of data points in each. So let's see, continents dot get. So if you want to retrieve a specific group, list the names of continents. Okay, let's say I put it in my other one. I think. Nope. No. Yeah, I'm kind of curious like why I put this question here. List the names of continents. What's that? Yeah. Oh, this is, I think, what it was. Contents of size. So in this case, it's telling you the size of number of data points in each specific group. So I grouped by continent, and yeah, it's basically telling you the number of data points. So the reason there's so many more, like 624 is essentially the number of countries times the number of years. So there's obviously, in this data set, a lot more countries in Africa that they collected data from. Yeah. How many unique countries are there grouped together in the Americas continent? So this is where I was going to do continents get group. This is how it works, Americas. And then I said how many unique countries. So there's the thing with pandas is there's actually multiple ways of doing things. So that's basically what I'm doing here is using the group by object. I've already grouped them by continent, and then I could select the country column and so how many unique countries. I think say dot unique, and that would actually list all of them. So in this case, I want to know how many. I can just say what's the length of that. There's 25 countries in the Americas within this group. The thing is that's probably not the ideal way of doing this, because like I was describing before, if you were going to use group by, it's because you want to do repeated things on all of those groups. In this case, I just selected Americas, and then that's basically what I was doing here. So there's no reason to actually do the group by for this. So one thing that's helpful is using aggregate functions on those group by objects. So in this case, the one I care about is getting the mean life expectancy. So here what I'm doing, I just say continents dot life expectancy. So this is like I was explaining before, where you select columns. I'm selecting the life expectancy column just by the dot notation, and then calling the mean function on all the continents individually. So basically what this is doing is grouping together all of those numbers in the life expectancy column. So this is a bit weird because what you're actually doing here is comparing life expectancy in these continents in different countries over all those different years, because we collected data from or someone collected data from 1952 to, I think, 2007. So I mean, you can see something in the numbers, but it's not necessarily the way you would actually want to analyze it. But just so you know. So you can also just change this and say, select expectancy this way. It'll give you the exact same thing. So that's what I'm saying here. Previous cell showed mean life expectancy values aggregated over all the years. So another thing we can do is group by multiple columns and use an aggregate function to get the mean life expectancy, population, whatever you want, in a specific continent in a specific year of interest. So here I'm going back to my original data frame, and I say group by continent and year, and then I'm giving it an aggregate function, np.mean. So I don't actually, here it's actually giving me all this data for all the leftover columns because I didn't select any. If I only cared about life expectancy like before, I could select the column here. So either with dot notation by saying dot life expectancy dot aggregate mean, or I could select it with like a list. So here basically this is giving me a new data frame with a constant year in the index, and then so in 1952, the mean population in countries in Africa was 4.5 million. You can see just general trends like life expectancy seems to increase over time. So this is a great way to quickly analyze data and repeatedly. So we might care about that, seeing this sort of data in Africa, in the Americas, and in all the continents. Yeah, so, okay. Here I have a question. What is the maximum life expectancy for a country in Asia? So let's try that. I guess. So I'm getting the group Asia. This isn't, once again, maybe not the best way of doing things because I'm using a group by, but only selecting a specific group from that group by. But then I want life expectancy and then max. So I'm seeing, okay, that's maximum life expectancy for a country in Asia. So the following question was then like, what's the country? When was this measurement taken? Like, I don't just want that number. I want to know, like, where do you think it was? So that's what I'm doing here. These are, I think, done the exact same way. So continents get group life expectancy. IDX max should give you the index of the maximum value. So 803, when we went for our, like from our original data frame, when there's those index numbers in bold, it would be the 803rd value. And I'm getting the same thing here, just selecting it in a different way. So here with the labeled selection, df.loc 803, and you see that the country with the max life expectancy was Japan in 2007, and it's giving you other data about it. It's in Asia. There's the GDP and population. So another useful thing that you can do with data frames is applying functions to the whole data frame. So what I wanted to explain here is how we can rank each country based on life expectancy. So one thing you can do here is basically what I'm going through is ranking the whole data frame by life expectancy. So I'm creating a new data frame where I sort the values by the life expectancy, and it's descending. So the value at the top has the highest life expectancy, and then I'm creating a new column. So that's what I'm doing here with, I just give it a new name, life expectancy rank, and then essentially I'm giving it a range. So this is a numpy function, and yeah, the length up until there, adding 1 so we don't have a 0. Just so you know what the data frame looks like, I just doing the head. So one question we want to see here is, what if we want to apply, rank each country based on max life expectancy for each year that data was collected? So this is one of these cases, because basically what I was trying to think of is what's an example case for how I would apply a function on group by selections. So what I did here is create a function, ranker, that assigns a rank to each country based on life expectancy, with one having the highest. So it takes a data frame and returns a data frame, and what it's doing here is creating a new column with the rank. So yeah, this is where you can use your apply function. So I'm taking the data frame where I sorted everything by year, sorted by life expectancy, and then grouping it by year. So there's different groups for 1952 versus 2007, and then applying my ranker function. So essentially I should see a whole set of things going on in 1952 and then have a new ranking for 2007. So now we can subset the new data frame by the year to view life expectancy ranks for each year. So that's what I'm doing here. I'm just looking at what's going on when the year is 2002. So surprise, surprise, Japan once again has the highest life expectancy in 2002. Let's see, so if I execute these, you can see what's going on in 2002. Alternatively, you can go back, and I think it was 1952 is when it first started. And Norway had the highest life expectancy there, so that's pretty interesting. Things have changed. 2007. Canada at the top of the list. So this is where I want to say, okay, let's subset by country equals Canada to see how Canada's ranking has changed over the years. So I'm taking, here what I did was I had my sorted by life expectancy data frame, and essentially I had originally just sorted all of them by life expectancy, and then in this case it's a group by object which I applied something onto. So I'm taking this data frame once again and basically selecting out of it only values where the country is equal to Canada. So you can see Canada at different years basically. So looks like life expectancy has constantly grown. So it's gone from, or there's that, but our rank hasn't always gotten better, basically. We seem to be hovering between 5 and 10. Yeah. All right, so up next was visualization. So finally getting some plots out of this. So it's important that you execute this line if you're using notebooks so that you can see your plots within the notebook. So this is just one of those magic commands. So that's what the percentage sign means. So there's a bunch of different plotting methods within Pandas. So in this case, what I basically want to do is a scatter plot with life expectancy and over different years. So each point is essentially a different country. So I'm basically just specifying on the x-axis I want the column year from the data frame, on the y the column life expectancy, and the kind is scatter plot. So I get this graph. It's not necessarily publication quality, but if the thing about it is afterwards you can sort of manipulate it if you know or you're familiar with matplotlib. So yeah. And I also want to plot GDP per capita versus life expectancy. So you can add in other parameters that you care about. So alpha just makes it like a little more shaded, so you can see where they sort of there's points on top of each other. The S is just the size of the marker. The marker here, O, makes a circle instead of a star or something else. So that's just like matplotlib, basically. So I thought this was a little interesting just because you're seeing how life expectancy and GDP per capita seem to interact. So basically, I thought these points specifically were interesting because they're not really, they've got really high GDP per capita, but it's funny that the life expectancy isn't way up high there, especially these. What's going on there? They've got a lot of money, but not living that long. Kind of, I mean, it's all right. So basically, this is where subsetting your data can get you answer some questions really quickly. So same thing, I do that's Boolean selection with a data frame where the GDP per capita is greater than 55,000. And you're seeing, oh, those are all Kuwait between the 50s and 1977. Basically, lots of money, maybe not a great place to live. Maybe, I don't know. So alternatively, there's lots of different plots. You can do a histogram here for univariate data. So I'm just giving it the life expectancy column. So it seems like there's a lot of countries which have, around a life expectancy of 70. Not so many countries are less than 40. As you can see, there's just not so many. Yeah. You can also give maybe more specifics here. So this sort of just calculates, I think, the bin width automatically, but you can tell it how many bins you want. So in this case, I said bins equals 200, and there's 200 bins, and that's what that looks like. So it's a spiky graph. I think there was, yeah, okay. Other examples are just like a KDE plot. So it's doing a kernel density estimation. You can give it all sorts of different parameters also if you want it to, like how wide the kernel would be. But you'd have to look in the documentation to know how it figures out what it wants. Yeah, okay. So next I wanted another exercise. Write a function that will take two countries as an argument and plot the life expectancy versus year for each country on the same axis. Because we're almost at 7, I'll basically just show you how I did this. So basically, taking two countries. Here, because I didn't want two plots, I made an axis. So x is equal to plot.subplot. And here, essentially, this is a list of countries, and it's drawing a plot for each country. So it's taking where the country is equal to the country that we care about, country 1, which is C here, plot X year life expectancy on the axis that I called over, or created over here. And then it loops through, so it goes for the second country, and this C becomes country number 2, and then it's plotting the same stuff. So you can work through that if you want. And basically what we're seeing is two plots where life expectancy goes up over time. The rate of improvement is better in Mexico. As you can see, the slope is higher, but general life expectancy in Canada is higher than Mexico. There's some other short examples here. So this is one where it's sort of an example of how you can mess things up in Pandas. So the example is Susie wrote some code to determine which country had the lowest life expectancy in 1982. What's wrong with her solution? So she's selecting country and life expectancy. So basically, data frame where the year within that data frame is equal to 1982. And then she's calling, she wants these specific columns, country and life expectancy, and then getting the minimum value. So she gets 38.445. You can remember from that histogram and I think like right at the beginning, the describe method that we had, I guess this is 1982. But anyways, it's not what she actually wanted. So you can say, do a quick lookup for what is going on here in 1982. So this is with our Boolean criterion, multiple criteria. Yeah. And you can see that in 1982, in Afghanistan, life expectancy was not 38.445. So basically, what I write here is the minimum function was applied to each column. So what we should have done, and I think this is actually, it won't matter, but this should be lock. Yeah. So this should be lock. So we're taking the index location where the data frame's year is equal to 1982, and we want life expectancy and the index at the minimum value. And then tell me what country it is. Yeah. Okay. Yeah, so the last part I just had was putting different ideas together. So for example, if you want to plot GDP per capita versus life expectancy in 2007 for each continent, you can basically write a for loop. And that's what I'm doing here, where continents, you're doing a group by on your continents, and then looping through each continent within those groups. So that's what I'm doing for continent in this data frame dot groups, and then yeah, so group equals content. Let's see. Maybe I can do that. So basically, yeah, I'm just looping through each continent, and if you do this, it's giving me a different plot for each one. And you can see different values. There's not too much for Oceania. There's some more examples where you can put them all in the same plot, but with different colors. I had another example or exercise where you might want to compare GDP life expectancy. Plot the GDP per capita against life expectancy for a given country. Yeah, I think it's good to practice these, but we're basically done out of time. There's at the end of the notebook, so after this, essentially, I thought this was sort of interesting just because you're seeing generally as GDP goes up, life expectancy goes up, or like some sort of graph like this. And Afghanistan was an interesting one where it doesn't seem to correlate. So you can look at other countries that you find interesting. But as far as checking like a few, most of them seem to follow this trend. Okay. Zimbabwe. So I mean, this basically just shows in a few lines of code how you can, because really we don't even need to print all this. It's essentially 2 lines of code. Something pretty quick that's interesting. And I think that's the whole point behind Pandas, is that you can rapidly subset data and create plots. Yeah, for things that you care about. So the last thing I just put in was using Seaborn. This was something that was fairly new to me, and almost right away I realized, whoa, that's pretty powerful. So I think the way people might describe matplotlib is it's fairly easy to get to plot simple things, but then if you want to plot more complicated stuff, there can be a whole lot of code and it's hard to play with. And with Seaborn, there's maybe certain things that are pretty complicated that you want to do repeatedly, and a lot of people want to do, and it allows you to do those really quickly. So these are just some examples. Another thing is just as soon as you import it, it makes things prettier. So I said import Seaborn as SNS, and then if we just run this all over again, it makes plots look nicer because it basically assumes Matplotlib doesn't make things pretty. So yeah, just as an example, I put set context to talk just so that it makes things big. And when you're giving a presentation like this, you want people to be able to see what's going on, but you can look through the documentation and you can maybe, it's got a few presets like made for poster, made for paper and things like that. But essentially what I'm doing is, this is a factor plot. So there's different data, whether it's categorical or numeric. And in this case, the categorical data that I'm interested in is these consonants. So I'm just telling the factor plot that the data that I care about is in the data frame. And on the x-axis, I want the year. So these are the years where the data was collected. Life expectancy on the y-axis. And then hue, which is the color, which is put in here. Make it a consonant. And then it gives me the plot with these confidence intervals. And I just put in the size because I think it was smaller if I didn't do that. So it allows you, as long as your data is clean in a tidy format, to rapidly do interesting things. So there's other examples that, if you want,
Quick question.
Yeah.
Does Seaborn work well with just regular NumPy arrays, or do you have to use the Pandas data frame structure?
I think it works with NumPy as well.
Because I see right here that you give it
A data frame, yeah.
default.
I think it works with NumPy. Do you know? It's typically with pandas. I'm sure that you'd have to look through the documentation and look at specific plots where you can give like an array, in this case, and an array here. And I think this one specifically, a regression plot, works that way. But then if you go down here, a linear model plot, it requires the data in like a tidy format in a data frame. But I'm sure that's in the documentation. So yeah, there's just some examples here. It's fitting a regression. You can tell it not to if you want to. So in this case, it's a scatter plot, basically. Yeah, there's just different examples. The other thing that's useful is like this sort of faceting perspective. I think this is much more typically done in R, but I'm not familiar with that, where you can just say like, okay, give me multiple plots. And like before, if I did the color was the continent, in this case, each plot on rows is for different continents. So it's just saying like, you'll see what the x-axis is on the last one. So this is one big figure. Yeah. So you can also do a factor plot here where you're just seeing the GDP per capita in different continents. Yeah. So I mean, I just wanted to show this so that people could know that it's out there, and it's helpful depending on what you need to get done. So one other thing also, I know if you're doing genetics, it does heat maps and matrices, like heat maps and
There's an example.
yeah. So you can see different heat maps like this, or I think this is relevant for genetics people, maybe. I don't know. I'm sure others. But yeah, just so you know, it's fairly quick. I don't know. I don't do any genetic stuff, so yeah. Any questions? No? Cool. So yeah, I think overall though, I'd say it's a good gateway, especially, I don't think anyone here like uses Excel, but it's a good way if you're doing a lot of stuff that way and you want to make things reproducible. Using pandas in a notebook is a good combination for just like analyzing tabular data in a reproducible way.